All right, welcome to the video. Today we're going to be looking at section 4.2 where we're going to be adding, subtracting, and multiplying polynomials. Our central question that we're going to answer is how can you cube a binomial? So in order to kind of look at that, we're going to look at some things that Um, should be a little bit of review. Hopefully you're familiar with it. Um, the two things that you should be familiar with, you've seen in previous math courses, is our sum and difference pattern and the squares of a binomial. The reason why we can use these formulas uh, from our core concepts is basically sum and difference patterns and squares of binomials is we create those formulas from foiling. So if you were to multiply out a plus b times by the quantity of a minus b, you would realize that the center common terms cancel each other out, so it's just going to be the square of a subtracted by the square of b. Same thing goes for the square of the binomial. So what that means is when you're looking at a cube of a binomial, a plus b quantity cubed is actually going to be a cubed plus 3a squared b plus 3ab squared plus b to the third. Same thing goes for the subtraction. The only difference is there's subtraction here and there's subtraction here. Reason why that comes into play is we we can expand that cube and solve it from there. So actually what we're going to do first in part A is we're actually going to prove the polynomial identity for the cube of binomial representing the sum. So if we look at that, what I'm going to do here is I'm going to expand a plus b quantity cube. So it's actually going to be a plus b times by the quantity of a plus b times it by the quantity of a plus b. So we expand that. So what I'm going to do first is I'm just going to multiply these two binomials. So when you multiply these two out, it actually turns into a squared plus 2ab plus b squared. Oops. And then we have left is a plus quantity of a plus b. So what we're going to do here is I'm just going to take this here and I'm going to distribute a to each one of the terms in that trinomial. So when I do that, I get a cubed plus 2a squared b plus ab squared. So now that I've taken care of that, now I'm going to take b and multiply it by these three terms to the left. So then that turns into plus a squared b plus 2ab squared, and then finally plus b cubed. Now I get to rewrite this in standard form and combine like terms. So my largest degree is, I'm going to say it's a to the third. You could say that this is a largest degree too, but what it essentially then what comes into play is alphabetical order. So since a is before b, I'm going to say a cubed, and that's the only one that's a cubed. Now I'm looking for anything that is an a squared. So it looks like I have an a squared here and an a squared here, and they just so happen to be like terms because it's a squared b. So 2 plus 1 is plus 3, so it's 3a squared b. Cross those out. Next is I got something with a to the first, so I have a to the first here, but they're also they're like terms because they're also b squared. They have the same letters raised to the same power. Add those together, it's plus 3ab squared. Cross those out, and all I have left is b cubed, and that is my uh, multiplied binomial when you expand it. And if you check the core concepts formulas, it's the same thing. So what we're going to do here is they want us to, for part B, they want us to use the cube of a binomial in part A to calculate 11 to the third power. So what you're essentially going to do is you're going to break up 11 into a sum. So what I'm going to do is I'm going to create this, instead of writing it as 11, I'm going to write it as 10 plus 3. You can write it, or not 10 plus 3, 10 plus 1 quantity cube. You could write it as any series of sums, but I feel this is just the easiest way to go about it. So essentially, this is A, and so 10 is A and 1 is B. So I'm just going to use this formula right here and insert 10 with A and 1 with B, and then go about and see what it solves with. So essentially, this is going to be 10 cubed, I'll just put parentheses around it, plus 3 times it by 10 squared times it by 1, plus 3 times it by 10 times it by 1 squared plus 1 cubed. So taking care of order of operation, 10 cubed is 1,000 plus 10 squared is 100, times it by 3 is 300, times it by 1 is 300, so plus here, 10 times 3 is 30, 1 squared, so that's just 30, and then plus 1, so 1,000 plus 300 plus 30 plus 1 is 1,331, and 11 to the third power, you should double check it, should be 1,331, which it is. So when it asks you to, find the product, you can certainly use the formulas, or you can just FOIL it out and uh, go from there. Kind of the choice is up to you. Sometimes I like to use the formula, sometimes I just like to expand it and multiply it out. So this one here, I realize is a sum and difference pattern. So anytime I see a sum and difference pattern, I just like to use the formula. So I'm just going to square A, which is 4n, so that's going to be 16n squared, subtracted by 5 squared, which is 25. For B, when we have the square of a binomial, that's a situation where, not only most students, I just feel comfortable just expanding it. So it's just going to be 9y minus 2 times by the quantity of 9y minus 2. Do the first, so it'd be what, 81y squared outside, so it's going to be minus 18y minus 18y plus 4. Combine the like terms here, so it's 81 squared minus 36y plus 4. Anytime you have your cube of a binomial, I would say a lot of people are pretty split with how to go about it. But I would say my personal opinion is let's use the formula. So here, AB is actually A and 4 is B when you look at it in the formula sense. So drop it down here. So it's actually going to become, and then in parentheses, AB cubed plus 3 times it by AB times it by 4, correct? Yeah, 4 plus 3 times it by, this one's to the second. This one's to the second, times by AB, and then it's going to be times it by 4 squared plus 4 to the third. So 3, 2, 1, 1, 2, 3. Yep. So we have it all here. So now in this particular one, you are using the power of power rule, which means you're going to attach the 3 to both a and b. So this is going to be a cubed b cubed plus, looking here, this is going to be just what, 4 times 3, so that's 12, and then this is going to be a squared b squared plus, over here, this is going to be 4 squared, which is 16, 16 times 3, which is 48, so this will be 48 AB, and then this will be plus 4 cubed, which will be 64. So my result is a cubed b cubed plus 12a squared b squared plus 48ab plus 64. So like I said, there's a bunch of these different problems here. I encourage you to review those. If there are something that you're just not certain of, please make a comment down below. I'll be more than happy to entertain those questions. So one of the ways, or one of the reasons why we are able to get these types of formulas is it comes from Pascal's triangle. Pascal's triangle is illustrated to the right here, where it has a series of ones along the outside, and then the values that are on the inside comes from the sums of the two values directly above it. So if you realize, so this is 1 and 1, that makes 2. 1 and 2, that gives you 3. 2 and 1, that gets you 3. 1 and 3 get you 4. 3 and 3 get you 6. 3 and 1 get you 4. 1 and 4, 5. 4 and 6, 10. 6 and 4, 10. 4 and 1, 5. If you were to go another row, you would put another 1 here. Between these two would be 6, because 1 plus 5 is 6. You would get 15, 20, 15, 6, and 1. And that keeps going on and on. But what essentially this is telling us is each row is telling us a certain power for a expanded binomial. So if you had, for like the first row, it's a plus b raised to the 0 power. Anything that's raised to the 0 power is going to be 1. If you have a first degree binomial, it's going to be 1a plus 1b. The quadratic a plus b quantity squared, this is the formula, 1a squared plus 2ab plus 1b squared. We really don't put the 1, but we're just adding it to show you that that's where it comes from. So essentially what they're telling us is we couldn't find the exponent of any binomial just by using Pascal's triangle to help us solve it. So, for instance, if we look at this example here, they want us to find x minus 2 raised to the 5th power. So if you look back at your Pascal's triangle uh, core concepts, it says that a plus b to the 5th power is going to equal a to the 5th plus 5a to the 4th b plus 10a to the 3rd b to the 2nd plus 5a b to the, so this would be what, a to the 2nd b to the 3rd. Oh no, I'm sorry, I wrote that wrong. There's two 10s. So this would be 10a to the 2nd b to the 3rd plus 5a b to the 4th plus b to the 5th. Sorry about that. And those values of 1, 5, 10, 10, 5, and 1 comes from Pascal's triangle. So, and in this case, x is a, and in this case, b is a negative 2. Because you could just write this as x plus negative 2 raised to the 5th power. It means the same thing. So, substituting in, I'm going to write in as x. I'm just going to put parentheses to help me. X to the 5th plus 5 times it by x to the 4th, and then that's b, so that's negative 2 plus 10x to the 3rd, and then this is negative 2 squared plus 10 times it by x squared, and then this is negative 2 to the 3rd plus 5 times it by x times it by negative 2 to the 4th, and then finally negative 2 to the 5th. All right, so x to the 5th is just going to be x to the 5th, nothing to change there, plus, looking here, negative 2, there's no x, but it's to the 1st power, so you just multiply that with the 5, so that's going to be negative 10x to the 4th plus, so I'll just cross that out that we took care of it. This one here will be negative 2 squared. Negative 2 squared is 4. 4 times 10 is what, 40? So this will be 40x to the 3rd plus, all right, so now I have negative 2 raised to the 3rd power, that's negative 8. Negative 8 plus, or not plus, times 10 is negative 80, so it'll be negative 80x squared plus, cross that out, negative 2 to the 4th will be a positive 16, times that by 5, that is 80, so I got 80x, and then it'll be plus negative 2 to the 5th power, and that will be a negative 32. So last thing I would do is anywhere there is like a negative, I'll just put that as subtraction. So my answer would be x to the 5th minus 10x to the 4th plus 40x cubed minus 80x squared plus 80x minus 32. Okay, I won't go through the whole thing, but let's set up 3y plus 1 quantity cubed. So I'll just write 3y plus 1 quantity cubed. So again, you're going to use the cube portion. This is A, this is B. Let's see what it looks like with the formula. So this one's going to be 3y to the 3rd plus 3 times it by a, which is 3y squared, times it by b, which is 1, plus 3 times it by a, which is 3y, times it by b squared, which is 1 squared, and then plus 1 to the third. So once you do all the math and expand it, you should get a result of 27y to the third plus 27y squared plus 9y plus 1. All right, if you didn't get that, again, please comment down below. We'll see where your error was, but sometimes it's just writing something incorrectly down. I understand there's a lot going on. I mean, I make mistakes as well, certainly. And that is being able to add, subtract, and multiply polynomials. Hope this helps. Until next time.